Good day, students! Welcome to Science Matayom 1 with Merivit Education Center. Let's get started with the lesson part. These are the three things you will be learning today. At the end of the lesson, you will be able to: Number 1. Know the families of the periodic table. Number 2. Demonstrate familiarity of the layout of the periodic table. Number 3. Write the symbol of elements in the periodic table on your own. Let's start. What do you call the symbols that are used to represent atoms and their isotopes? You're right! The symbols that are used to represent atoms and their isotopes are called nuclear symbols. What are the three components of the nuclear symbol? Awesome! The nuclear symbol consists of three parts: the mass number, the atomic number, and the chemical symbol for the element. Let's try this. See the diagram above? Can you write the nuclear symbol for the element carbon? Just give it a try. All you need to do is guess the correct word from the unanswered boxes. Select the answer within the word bank. I know you can do it. This is how it should look like when we are done. Do we have the same answer? Excellent! How to write the nuclear symbol for the element carbon? All right, C is the symbol of the element. 6 on the upper left corner, which is the atomic mass or proton number, and 12 under the symbol of the element, which is the atomic number or the relative atomic number. Writing the nuclear symbol is connected to our topic today, which is the periodic table of elements. The history of the periodic table. Did you know who wrote the first extensive list of elements in the periodic table? Correct! In 1778, Antoine Lavoisier wrote the first extensive list of elements containing 33 elements and distinguished between metals and nonmetals. He also classified elements into 4 groups. These are the elastic fluids, nonmetals, metals, and earth. Do you know who attempted to relate the elements by proposing Dalton's law? Excellent! In 1803, John Dalton proposed Dalton's law, describing relationship between the components in a mixture of gases. Amazing! Do you have any idea how did John Newlands arrange the known elements? Awesome! In 1864, John Newlands arranged the known elements in order of atomic weight and observed similarities between some elements. Have you ever heard the name Lothar Meyer? Good! Now, how did Lothar Meyer develop the early version of the periodic table? Wonderful! In 1864, Lothar Meyer developed an early version of the periodic table with 28 elements organized by valence? All right. Who isolated radium and polonium? You're right. Marie and Pierre Curie isolated radium and polonium. In 1898, the Curies discovered the existence of the elements radium and polonium in their research of pitchblende, but successfully isolated them on April 20, 1902. Where do you think radioactivity came from? Amazing! In 1900, Ernest Rutherford discovered the source of radioactivity as decaying atoms. Who determined and modified the periodic table, and who identified the lightest first ever synthesized transuranium element? Can you name them? Perfect! In 1913, Henry Moseley determined the atomic number of each of the elements and modified the periodic law. And in 1940, Edwin Macmillan and Philip H. Abelson identified neptunium, the lightest and first synthesized transuranium element found in the product of uranium fission. In 1940, transuranic elements were being synthesized. Can you guess who did it? Excellent! In 1940, Glenn Seaborg synthesized transuranic elements, or the elements after the uranium in the periodic table. And for sure, the next elements are yet to come. What is the periodic table? Do you know when the periodic table developed and who created it? Awesome! The periodic table is a chart that organizes elements according to their increasing atomic numbers and their chemical and physical properties. It was developed in 1869 by a man named Dmitry Mendeleev, who was a Russian chemist and inventor. Can you tell how many elements Dmitry Mendeleev discovered during his time? You're right. In his time, there were only 60 elements discovered, but he left blank spaces on his table for undiscovered elements. He actually predicted that unknown elements would have properties very much like the elements above them on his table. How genius he was, right? The picture above are the elements that Dmitry Mendeleev discovered. The yellow-green are elements known to him, while the purple ones are not. How is the periodic table being arranged? Exactly. The periodic table is arranged in columns and rows. Did you know that the periodic table has periods and groups? Yes, you heard it right. There are 18 groups on the periodic table, the 18 vertical columns. Each column on the periodic table is called a group. If there is a group, there is also a period on the periodic table. Exactly. Each row on the periodic table is called a period. Did you know how many periods are there? Wonderful! There are 7 periods on the periodic table. Here, some more. Bring out your textbook and any other coloring material. Open your book on page 104. Listen carefully to the instructions that I am going to tell you. Ready? All right. Can you find the zigzag on the periodic table? Amazing! There is a zigzag that separates the periodic table into two slides. What do you call that zigzag that separates the periodic table into two slides? Awesome! The zigzag is called the staircase. Now darken the staircase red on your periodic table. See the picture in the slide. Good job! Shade hydrogen pink on your periodic table and label it a nonmetal. To the right of the staircase, you will find all the nonmetals. To the left of the staircase, you will find all the metals. Label them except for the element hydrogen, which is found on the left side. Look at the picture on the right side. This is what your periodic table on your book would look like if you followed the instructions I told you earlier. Does the periodic table that you did look exactly the same in the picture that you see on the slide? Awesome! Let's proceed. Can you find the metalloids in your periodic table? Fantastic! Directly on the either side of the staircase, you will find the elements called metalloids, or also known as semimetals. Now shade the metalloids in your periodic table with color purple and label them. Can you follow? There are 7 of these elements. Have you finished? Now, does your work look the same as what we have seen on the screen? Well done! The periodic table have families. Yes, there are. Can you name them? Excellent! The following slides are all about the periodic table families. The alkali family. So what's with the alkali family? Right. The alkali family is found on the first column of the periodic table. They have 1 valence electron. Can you give the names of the elements that belong to the alkali family? Excellent! Lithium, sodium, potassium, rubidium, cesium, and francium are all alkali metals. The alkaline earth metals family. So what do you know about them? Awesome! The alkali earth metals family are never found uncombined in nature, and they have 2 valence electrons. These include beryllium, magnesium, calcium, strontium, barium, and radium. The transition metals. What are the transition metals? Great! Transition metals include those elements in B families. These metals are probably most known to you, and they are good conductors of heat and electricity. For example, The charger of your phone is made up of copper. Can you name some aside from the example that I've mentioned? Wonderful! We have scandium, titanium, vanadium, chromium, manganese, zinc, cobalt, nickel, and the rest of the elements highlighted in red are all transition metals. Iron in air, which gives iron oxide, is also an example of transition metal. In other words, all elements that you see at the middle of the periodic table are transition metals. So, how was it? Isn't it amazing that you will be filled with all the knowledge about the wonders of the periodic table? Well, here's more. The boron family. What can you say about the boron family? Good job! Atoms in this family have 3 valence electrons. It includes a metalloid boron, and the rest are metals such as gallium, indium, thallium, and most of all, aluminum metal, which is the most abundant metal in the Earth's crust. It's not just that. We have the carbon family. Now, what are the elements of the carbon family? Fantastic! From germanium down to ununquadium belong to the carbon family. This family have 4 valence electrons, and actually, they're called as bases of life. Do you know why? Exactly. The carbon family are important in daily life and in industry. The allotrope graphite is used in pencils and rockets. Living organisms, proteins, food, and organic building materials all contain carbon. Yes, you heard it exactly. What makes up 78% of our atmosphere? Excellent! The nitrogen family makes up 78% of our atmosphere. Now, what are the nitrogen family? Awesome! The nitrogen family have 5 valence electrons and tend to share electrons when they bond. It includes nitrogen, phosphorus, arsenic, antimony, and bismuth. We're almost halfway through the 9 families of the periodic elements. So fasten your seatbelts. Although nitrogen encompasses 78% of the atmosphere, oxygen is the most abundant element in the Earth's crust. Do you know which family does oxygen belong? You're right. Oxygen belongs to the oxygen or the chalcogens family. So what are oxygen or the chalcogens family? Nice. This family has 6 valence electrons, and most in this family share electrons when forming compounds. Can you name the chalcogens family? Amazing! Chalcogens or oxygen family includes sulfur, selenium, tellurium, polonium, and of course, oxygen itself. The halogens family or the salt makers. What are the halogens family? Well done! Halogens are the most active nonmetals because they have 7 valence electrons. Elements in this family are never found free in nature. They only need to gain one electron to fill their outermost energy level. They are known salt makers because they react with alkali metals to form salts. Fluorine, chlorine, bromine, iodine, and tennessine were given names from the Greek root hal, or salt, and gen, to produce. The noble gases or the inert gases family. Now, cities at night would be rather boring without all the bright lights. Yes, the next family in the periodic table provides colorful illuminations and help make things much more visible. Do you know what they are? Terrific! We call these lights neon lights, but they use several gases to make different colors. These are what we call the noble gases family. Do you know what those noble gases are? Absolutely. They are composed of stable gases, or known as the non-reactive or inert elements. This group have 8 electrons in the subshell. Helium, neon, argon, krypton, xenon, and the radioactive radon are the 6 naturally occurring noble gases. The lanthanides and the actinide series are also known as rare earth elements. Can you guess where you can find the lanthanides and actinides in the periodic table? Very well said. These are the 2 rows under the periodic table. Lanthanides are a group of 15 chemical elements with atomic numbers 57 through 71, while the actinides family comprised of 15 elements starting from actinium, or Ac, with atomic number 89, to finish up with lawrencium, or Lr, with atomic number 103. Well, you probably heard also plutonium, or Pu, since it was used in atomic bombs. Absolutely, you heard it right. Plutonium is used for atomic bombs. One element of the lanthanide series and most of the elements in the actinide series are called transuranium. Do you know what does it mean? Awesome! Transuranium means synthetic or man-made. All right, open your workbook. Answer page 63, items 1 up to 4. Bring your task during the opening of the school. Scan me for the vocabulary review. That's all. See you on the next episode.